Welcome back. Now let's look at this problem and derive the beta hat. So from this equation here, we obtain now the sum of squared residuals just as before, but now we work with the adjusted variables where we deduct their mean, which means there is no need for the constant term anymore. So it simplifies our problem. So again, we obtain here the sum of the residual, which is now my y star, minus the prediction, which is beta hat xi star, and I would then put this to the power of 2. So this would be my sum of squared residuals, which I now try to minimize by selecting the beta hat. So we have only one variable, so I can just do a normal derivative. We look into the first order condition, and when we do this, the 2 goes front. Again, this is chain rule. If you have any questions or comments, just please leave a comment below. And we just leave now the content inside the brackets. Just move a bit to the right, and we get here the minus xi star, and this is equal to 0. Now this is our first order condition. Good. Now it might be useful to think a little bit about variances and covariances before we continue. So we will get back to this in a minute. The variance of a random variable, say x, is simply the expected value of x minus x upper bar power of 2. Yeah, this of course can be multiplied out, but this is basically it. We already have our adjusted variables, so this would be of course then simplified using our notation to x star, and this would be then to the power of 2. Now the covariance of xy is the expected value of x minus x upper bar, y minus y upper bar. And again, because we can work with standardized variables, we would have the expected value of x star y star. This is basically what we need here. So this is kind of useful, and we will now use that to simplify our first order condition. Alright, so the 2 we can get rid of, the minus 1 we could also get rid of, and we can now just simplify this a little bit. So multiplying this out, we have here the sum of yi star xi star minus beta hat, the sum xi star squared, and that's equal to 0. And now we can basically use what we have used above here. In a second, we can just rearrange that. So we obtain the beta hat is equal to the sum yi star xi star divided by the sum xi star squared. Or I can also write this, of course, in terms of a covariance and variance. Okay, so I obtain here the covariance yi star xi star, and here I have the variance of xi star. So that's basically it. So this would be our estimate. And of course we notice that the covariance is of course related to a simple correlation coefficient. Yeah, so this is of course what we are looking at here, because end of the day, yeah, that's the relationship between correlations and regression models. Of course, have in mind we only have one explanatory variable in this particular case. Good, so now we derived our optimal parameter values, these point estimates for the intercept and the slope coefficient, and we learned something about standardization. So once you standardize, the intercept drops. And as I said, this is a very common procedure which you find a lot in machine learning algorithms. Great, I see you in the next session.